So I recorded this part of video अघि नै तर while I was editing I found out that this part was mute. I don't know why the audio did not get recorded, so I'm repeating this again. This video might come really late because I'm recording this part again, so let's get to the final part of this chapter, which is chapter 5, the use of statistics in business and finance. अब statistics business and finance मा use गरिन्छ तर किन गरिन्छ हैन. So के अरे to get the central tendency variable uncertainty, central tendency भनेको चाहिँ possible outcomes भयो. it essentially means the average. कुनै पनि data set को or कुनै पनि decision को outcome को average value निकाल्ने त्यसलाई सेन्ट्रल टेन्डेन्सी भन्छ. अनि भेरिएबिलिटी भनेको डिस्पर्जन हैन. त्यो आउटकम चाहिँ कतिको डिस्पर्स्ड और के अरे कतिको डिफरेन्समा छ फ्रम द एक्चुअल डाटा सेट्स हैन. एन्ड देन अनसर्टेन्टी भनेको अब त्यो आउटकम कतिको अनसर्टेन छ त्यही भयो हैन. फर्स्टमा चाहिँ टु मेजर द सेन्ट्रल टेन्डेन्सी अर द एभरेज. अब एभरेज किन फाइन्ड आउट गर्छ? एभरेज फाइन्ड आउट गर्नुको कारण भने आउटकम प्रोबेबल आउटकम्सहरु पत्ता लगाउन है. अनि टु फाइन्ड द सेन्ट्रल टेन्डेन्सी वी हेभ 4 मीन, मिडियन, मोड अनि एक्सपेक्टेड भ्यालु. अनि यहाँ ओके फर्स्टमा मीन छ. मीन भनेको द अर्थमेटिक मीन इज द अर्थमेटिकल एभरेज अफ a data set. अब कुनै पनि data set छ भने we add up the value of every item and divide by the number of items. So for example, first one let's take 50, 52, 45, 65, 70 and 68. For example, in our summation will be 350, and then we divide it by the 1, 2, 3, 4, 5, 6 divided by the number of items, which is 6, and we get 58.33%. The 58.33% is the arithmetic mean or arithmetic average. And then we have median. Median भनेको चाहिँ के हो? When there are extremely distorted extreme values हरु हुन्छ नि त्यो डाटा सेटमा extreme values, extreme outliers छ भने त्यसले चाहिँ mean or arithmetic average लाई distort गर्न सक्छ. So we use a median. Median मा चाहिँ के हुन्छ भन्दाखेरि so same data set 50, 52, 45, 65, 70 and 68. And if there is an outlier like 300, then what we do is अब median भनेको चाहिँ त्यसपछि बिचको भ्यालु we first हामी यिनीहरुलाई एउटा अर्डरमा राख्छौं like smallest to largest. yes 50, 51, 52, 45 यो यिनीहरुलाई फर्स्टमा हामी एउटा अर्डरमा राख्छौं which is 45 plus 45 50 51 52 65 68 and 70 and 300. अब यिनीहरुलाई अर्डरमा राखेपछि if the data set को number is even, we take the बिचको दुईटा data and find out their average like 1 2 3 4 5 6 7 8. यहाँ 8 वटा छ. so 52 र 65 प्लस गर्ने अनि उनीहरुको एभरेज निकाल्ने. .5. So this is the actual median. यो सब यहाँ सब wrong भएछ. So 58.5 is actually the average value of this, जुन चाहिँ 300 distort गर्छ अनि distort गरेपछि चाहिँ यो 92.85 आउँछ त्यो अघि मीनकै अर्थमेटिक वेमा निकाल्यो भने. So extremely distorted or extreme outliers भएको data sets मा we use median. And then we have got mode हैन. मोड भनेको चाहिँ के हो? मोड भनेको चाहिँ फ्रिक्वेन्सी बेस्ड हुन्छ हैन. कुनै पनि डाटा सेटमा जुन नम्बर मोस्टली रिपिटेड अर मोस्ट फ्रिक्वेन्ट छ त्यो डाटा सेट त्यसलाई चाहिँ हामीले मोड भन्छौं. अनि यो कता युज हुन्छ? ओके फर एक्जाम्पल यो एक्जाम्पलमा 38 39 40 41 41 41 छ हैन. सो 41 इज द मोड अफ दिस डाटा अनि यो चाहिँ कता युज हुन्छ भन्दाखेरि इमेजिन अ शू शप अनि त्यहाँ चाहिँ शू साइज सेल को अब डाटा हो यो होइन सो 41 साइजको सुज धेरै बिग्छ भनेर we identify through mode and then the shoe shop owner can restock on 41 size shoes so उनीहरूको सेल भइराखोस् अनि this is a real life applicability small simple example and then we have got expected value so what is expected value भने when there are two outcomes two possible outcomes अब त्योबाट कुन हुन्छ थाहा हुँदैन so we need to find out an expected value or average हुन्छ त्यो नि एभरेज जस्तै हो हैन so first we have got first scenario and second scenario first scenario मा 60% we have 60% chance of making 800,000 profit and 40% chance of making loss of 500,000 profit so expected value the formula for expected value is summation of probability into outcome so यसलाई यो न्यूमेरिकली गर्दाखेरि we have 60% chance of getting 800,000 profit and 40% chance of making 500,000 loss and then we use the formula and get 480,000 and minus 280,000 and then we get final value of 280,000 यसको मतलब चाहिँ के हो when we have both scenarios of making either 60% chance of making profit of 800,000 and 40% chance of making 500,000 loss and we use the expected value formula we get the probability or possibility of making 280,000 profit and then we have got measuring dispersion so dispersion भने के हो so the outcomes we find with the help of central tendency that might not always be the most accurate because there might be some difference between the average and the other data available in the data sets so we use dispersion to find out how inconsistent or how consistent the average is to the data set and first we have range भने के हैन we just find out the difference between the highest and the lowest value so if imagine a data set has the highest value 125,000 and lowest value 50,000 we find their difference and the difference is 75,000 75,000 is the range of this data set it is not the most effective because it ignores everything in between then we have got standard deviation and then we have got standard deviation so what is standard deviation standard deviation is how much each value of the data differs from the outcome or average we found out हैन so यसको लागि there's a simple formula which is root summation of x minus mean whole square divided by n अब standard deviation find out गर्ने एउटा whole step by step process so which we'll see so imagine this is an imaginary data set for us अनि so first step of finding standard deviation is first we need to find the mean so arithmetical mean is 2.83 and then we have to subtract each of the data from the data set with the mean which is x minus 2.83 and 2 minus 2.83 equals to minus 0.83 and then 3 minus 2.83 is 0.17 and 4 minus 2.83 is 1.17 and so on and त्यसपछि after we get the difference after we subtract each value from mean and get the difference we need to square the difference and the third step your second step and then the third step is to square each differences अब सबलाई स्क्वायर गरेपछि 2 को difference को square we get 0.69 3 को difference को square we get 0.03 and yeah 2 को difference we get 2 को difference को square we get 0.69, and 3 को difference को square we get 0.03, and 4 को difference को square we get 1.37, and so on. And then after we find the difference, we need to find the sum of all those squared differences, and then we need to divide by the number of averages, and then we'll find after that we get variance, and the variance is rooted, find the actual standard deviation. So standard deviation is 4.85, which is 4.85%. So now coefficient variables भनेको चाहिँ के हो? Coefficient variable भनेको यस्तो dispersion tool हो that helps us compare risk or variability between two data sets, even if their averages are different हैन. दुई डाटा सेट्सलाई हामीले कम्पेयर गर्नु हेल्प गर्छ. अब उनीहरुबाट कुन चाहिँ लेस रिस्की छ, कुन चाहिँ हायर रिस्की छ टु डिसाइड अनि चुज हैन. सो इमेजिन सेल्स हैन, यहाँ सेल्स पर्सन ए छ, सेल्स पर्सन बी छ रे, एन्ड द average sales in thousands is 100 for salesperson A and 200 for salesperson B. The standard deviation, how much the person deviates, how much the sales deviates of each person is 10 for salesperson A and 40 for salesperson B. And this हामी coefficient variable को formula, which is T by mean, गर्यौं भने 10% or 0.1 or 0.2 आउँछ. सो यसको मिनिङ के हो भन्दाखेरि the deviation or dispersion of is 10,000, which is 90,000 to 110,000, and the dispersion of dispersion or deviation that salesperson B might have is 160,000 to 160,000 to 240,000. So even though the sales average of salesperson B is more higher, due to the coefficient variable also being higher, it seems more risky. And the salesperson B is more safer in comparison to salesperson B, even though its sales averages are low. अब it will be more safer हैन. धेरैमा धेरै 10% deviate होला. तर in the case of B, you have the chance of having like 40,000 deviation. You will make 40,000 less sales. So B is more risky than A. अनि यस्तै situations which one is more risky and which one is not भनेर त्यस्तो like choose गर्नलाई help गर्छ coefficient variable. We have normal distribution. A normal distribution भनेको के हो? Normal distribution is just a pattern of how things happen in real life. अब त्यो चाहिँ के हो भन्दाखेरि visual or graphical representation of how data occurs in nature. के अब यसको मतलब चाहिँ के हो भन्दाखेरि if we take sufficient number of data that occurs in real life, त्यसले चाहिँ जहिले बेल शेप बनाउँछ भन्छ, like यस्तो शेप. अनि यसमा चाहिँ के हुन्छ, this अब एभरेजेसको एभरेज चाहिँ mean equals to median equals to mode. Everything, all the averages are the same. अनि त्यसपछि अर्को के भन्छ भन्दाखेरि अब imagine this is a bell shaped curve हैन. अनि यसमा चाहिँ के भन्छ, this is the average. अनि 68% of the data चाहिँ plus minus 1 standard deviation भित्र lie गर्छ हैन. And then 95% of the data lie within plus minus 2 standard deviation, and then 99.7% data lie within plus minus 3 standard deviation. अब यसको मतलब के हो? So what does that even mean हैन? So imagine we have a mean of sales को imagine गरौँ. Sales सेल्सको नम्बर छ यहाँ हाम्रो अनि our average mean is 100,000 and this is our mean 100,000 भयो भने फर्स्टमा we have got plus minus 1 standard deviation यसको मतलब 10% into average plus average. So what does this mean? Our 68% of our values lie within 90,000 to 110,000 and plus minus 2 standard deviation equals to plus minus. Our 95% of data lie within 80,000 to 120,000 rupees and plus minus 3 standard deviation. Our 99.7% data lie within 70,000 rupees to 130,000 rupees. And visually it's like this. This is not the best bell shaped. But okay, 68% of our sales is sales lie within 90 to 100,000. 95% lie within 90 to 110 and 80 to 120 and 99% lie within 70,000 to 130,000 and there are only few outliers यता चाहिँ. So next we have skewness. Skewness भनेको के हो? Skewness is the measurement of asymmetry distribution. त्यो अब कुनै पनि ग्राफको डिस्ट्रिब्युसन कुनै पनि डाटा सेटको डिस्ट्रिब्युसन कतिको एसिमेट्रिकल छ. सो यहाँ तीनटा छ हैन. सिमेट्रिकल डिस्ट्रिब्युसन यो भने चाहिँ अब नर्मल डिस्ट्रिब्युसन भयो अनि पोजिटिभली स्क्युड र नेगेटिभली स्क्युड छ. पोजिटिभली स्क्युडमा चाहिँ नाउ के रे पोजिटिभली स्क्युडको फिचर्स के हो? फर्स्टमा it's like mean is greater than median and median is greater than mode. So mode चाहिँ एकदम mode is the lowest भनौं न हैन. अनि अघि भर्खर पढाए mode भने फ्रिक्वेन्सी हो. सो यसले के बुझाउँछ भन्दाखेरि the large number of data is lower than the mean or actual average भन्दा large number of data is lower. अब यसको रियल लाइफ मिनिङ के हुन्छ भन्दाखेरि इमेजिन दिस इज लाइक अब एक्स र वाइ एक्सिस. एक्समा चाहिँ सो यसलाई बुझ्नुलाई एउटा ग्राफ बनाएको छ. एक्स एक्सिसमा एज हुन्छ, वाइ एक्सिसमा नम्बर अफ पिपल अर पपुलेसन हुन्छ हैन. सो इफ दि पोजिटिभली स्क्युड छ भने यस्तो हुन्छ हैन. What the fuck? So if it's positively skewed यो यस्तो ग्राफ भन्छ हैन. अब यसमा चाहिँ के हुन्छ? मोड यता हुन्छ. अब what is this showing? अब यो डाटा सेटमा के देखाइराछ भन्दाखेरि यो सर्टेन पपुलेसन, यो सर्टेन सिटीको पपुलेसन भनौं हैन. अब यो ग्राफले के देखाइराछ भन्दाखेरि यो सिटीको पपुलेसन अब यो सिटीको मेजोरिटी अफ द पपुलेसन लाइभ इन द यंगर एजेस 20 एज भनौं अनि यहाँ चाहिँ 70 भनौं हैन. अब एभरेज एज 30 थियो रे, म्याक्सिमम एज 70 थियो रे. अनि यसको मोड 20 भएपछि यो ग्राफले के देखाइरहेछ भन्दाखेरि the average the majority of the population is in the younger side, which is 20 भनेर देखाइरहेछ. अनि same example for negatively skewed को feature के हो भन्दाखेरि mode is greater than median and median is greater than mean. The graph goes like this. So the mode is the highest frequency, सबसे धेरै चाहिँ mode हुन्छ, and then median and then mean. So mode is greater than median and median is greater than mode. Mean भनेको mode is the highest, अनि so यो next city को population चाहिँ maximum चाहिँ the older side मा lie गर्छ. Imagine 45. So skewness ले चाहिँ tells us if our data is lopsided भनेर. So त्यसको मतलब के हो, हाम्रो डाटामा majority or extreme number of value कुन साइडमा लाई गर्छ, is it lower than mean or is it higher than mean, त्यही एक्सप्लेन गर्छ. So finally we have kurtosis. Kurtosis is, I found kurtosis to be a little complex, but I'll try my best to explain it. So kurtosis भने के हो, kurtosis is a measure हैन, like it's a tool to measure the risk of extreme values of a data set by the use of by showing fatter or heavy or light tails. अब we have got first मा mesocrutic kurtosis छ हैन. mesocrutic kurtosis भनेको चाहिँ normal kurtosis भयो. यसको टेलहरु normal moderate tails हुन्छ. So यसको probability of getting, अब imagine this as an investment return भनौं 0% 0% देखि 100% छ and the mean is 50% हैन. So mesocrutic मा चाहिँ एकदम light tails हुन्छ हैन, which shows that the probability of getting extreme values like light भन्दा नि moderate tails हुन्छ, which shows that the probability of getting extreme values like 0 or 100 is moderate, making this investment moderately risky, not very high or not very low. And then we have got leptokurtic kurtosis. अब यसमा चाहिँ के हुन्छ, this is like a more risky kind of investment because it has high peakness and this is a heavy or fatter tails. यसको मतलब चाहिँ the probability of getting extreme values like 0 or 100 is very high, अनि so यसको fatter tails हुन्छ. So the risk is the outcome हुन्छ नि, कति extreme values आउने risk is very high. Next we have platykurtic. Platykurtic भनेको चाहिँ below normal kurtosis भयो. यसको tailsहरु एकदमै light or thin हुन्छ. So the probability of getting extreme values like 0 and 100 is very low. अनि यसको most of the returns or probability चाहिँ near to the mean नै lie गर्छ. And that's it for kurtosis. It's kind of complicated, and I'll be linking aru teacher kunai teacher ko kurtosis explain gare video in the description, so you can understand it in more depth. And that's it for today. Thank you very much.